Alright, so sometimes we're given an angle theta, and we're asked to simply calculate the value of tan of that angle. Okay. Remember that all this means, when whatever number you get in your calculator, when you press tan of that angle, you get the ratio of the opposite side to the adjacent side. You'll just get it in a decimal form. Your calculator will never put that ratio in fraction form. Sometimes you can, but sometimes you can't. It depends on what angle you're dealing with. Okay, so we're going to calculate the following to 4 decimal places. Usually ratios in trigonometry are rounded to 4 decimal places to keep things nice and precise. Okay, so tan 50. Again, remember, I'll just draw a quick diagram here. This is a triangle with an angle of 50 degrees. And if we knew the two sides, opposite and adjacent, to that triangle, this is opposite and adjacent here, right? When we enter tan 50 in, we would get the same thing if we took the opposite side and divided it by the adjacent side. But we don't know that in this case because all they give us is an angle in a triangle. Okay? But we can know the ratio, or at least the approximation for the ratio. So you just go in your calculator and you enter in, you press the tan button, and then 50, and you should get 1.19175, which rounds to 1/8. Okay? Tan 38 is done the same way. Just press tan and then 38. You should get 0.7813. Tan 45 is an interesting one. It equals 1. What? How did that get there? You'll learn more about that next year. And tan 25 is 0.4663. Okay? So again, these numbers here, even though they look obscure and random and out of place, and there's definitely not really any pattern to them, just remember that these are the ratios between the sides opposite these angles to their adjacent sides. Okay? Alright, so we've set up ratios and that's all well and fine. But another amazing ability of tangent is to find angles within a right triangle. And again, this is something you haven't really done before, right? You've been able to find sides of right triangles using Pythagoras, but I'm about to show you how to use trigonometry to find unknown angles within a right triangle. Okay? So to do this, we're going to use something called the arctan function. Okay? And we're going to use it on the ratio that tan theta is equal to. And that might sound strange, okay, but let me just illustrate that with an example. Okay, so let's say that we had this ratio right here. Tan of some angle in my triangle is equal to 5/4, and we need to draw a triangle to represent that. Okay, well, let's just draw a quick triangle here. And I'm going to label one of the angles here theta. I'm going to label this angle theta. Alright, so what is this ratio telling me? Well, you'll remember that the tan of an angle is equal to the side opposite that angle over the side adjacent to that angle, right? So this 5 here is the length of the side opposite theta. And this 4 here is the length of the side adjacent to theta. And that helps me to add a little bit more detail to my diagram here, right? Here's theta. The side opposite to it, my ratio here told me was 5, so this is the side opposite theta, so that's 5. And the side adjacent to theta is 4. Interesting, right? And you could use Pythagoras to find this third side here if you wanted, but we want to know what this angle is. Right? And again, this isn't something you've done before, so brace yourself for very exciting moments in your life. Here's how we do this, okay? So tan theta is equal to 5/4. How do we solve for this theta? How do we get something? How do we do our algebra here so that we just get theta equals some number? Well, here's how we do that. We use something called arctan. Okay, or another way it's written is tan to the -1. You can see arctan and tan to the -1. Those are essentially the same thing. Okay, so here's how we do this. If you go to your calculator and you look at the tan button, I'll just draw a picture of the tan button here. Okay, so here's the tan button. Oh, it's in capital letters, so tan. Okay, and if you look above the tan button, just to the left, a little bit up and to the left, you'll see in tiny little letters it'll say tan -1. And on my calculator, I have a TI-83, and it's yellow. I think on the TI-84s it's green. Maybe it's blue. I'm not sure. But it's this function right here. It's right above the tan button. Okay. So to access that function, what we do is we press that second button, and then we press tan. And your calculator should pop up with, it should say tan -1, and then it'll start your bracket. Okay. The thing that we want to put inside these brackets here is this ratio that the tan of that angle is equal to. Okay. So you put tan -1 of 5/4. Okay, the ratio that angle is equal to, and that will solve for theta. Okay, essentially, if we go arctan of the left side, this is just to kind of explain what we're doing. Okay, this will bring out the theta just by himself. It basically undoes our tangent function. Okay, and on the right side, you know, whatever you do to one side, you have to do to the other. So we have to arctan the other side, right? So what we've accomplished over here is we've just isolated theta. And what we've accomplished on the right side is we found the value of theta, right? So we're going to arctan the ratio that we had, and you've probably done it by now. That's equal to 51 points. I'll just round it to the 10th place value. 51.3 degrees, right? So this angle right here, this is 51.3 degrees. And that's very interesting, right? You've never done something like this before. You've never been given sides of a triangle and been asked to calculate the angle, or an angle inside that triangle, and here we've accomplished that. And again, the way we do it is we arctan this ratio right here. We arctan the ratio that the tan of that angle is equal to. So let's try a few more here. What angles would give the following tangent values? Okay. Again, all these are just ratios in decimal form that the tan of an angle is equal to. And to find the value of the angle, we just arctan these ratios. So to find theta in this case, we'd go arctan of 0.5095. So again, second tan 0.5095. And that gives 26.9988. 8, which I guess we can just round it to 27. It's pretty close. Okay, so we'll just round that to 27 degrees, right? It's very interesting, right? 27 degrees. Tan of 27 is equal to 0.5095. And you can just verify that in your calculator, right? Just go tan 27, and you should get really close to this, right? Tan 27, you get pretty much the same thing, 0.5095. Very interesting. What if the ratio was 0.5543? What would the angle be there? Well, again, we just arctan 0.5543. So just do that on your calculator quick. 0.5543. We can arctan that. And we get approximately 29 degrees. And the last one, we just arctan 1.4653. And we get 55.7 degrees. Okay, so that's interesting, right? We've been given the ratios, and based on those ratios, we can use the arctan function to find the actual angles that those ratios are based on.